Hello and welcome to Lovett Learning. I am Gavin Lovett and today we're talking about the commutative property. Now, quick disclaimer, yesterday we talked about the associative property and I realized after recording the video that second example that I gave, 20 divided by 2 multiplied by parentheses 5 plus 5 was actually a example of the commutative property, not the associative property. So I apologize if that confused anyone. If you do have any questions, please leave a comment down below. Visit loveandlearning.com, leave a comment there, or email me. Any of those options are great ways to get a hold of me, and you can ask questions and I will try to answer them. So, commutative property. The commutative property states that you can rearrange the order of individual terms. Sorry, let me get rid of that for you. Individual terms in an addition or multiplication expression. So, and without altering the answer. So, you may be asking, well, how is that any different than the associative property? Well, the associative property is actually groupings. So, if you have 3 plus 4 in a group added to 5, that's the same as 3 added to 4 plus 5 in a group. While the commutative property is saying 3 plus 4 is the same as 4 plus 3. And I'll show that here in a second. So the commutative property, addition A plus B equals B plus A, multiplication A times B equals B times A. And this may be something, intuitive where you can look at it and say, oh yeah, well, I mean, if you have A plus B, flipping the order shouldn't change the answer, right? And this property defines that for us. So if we look at this, 3 plus 4, let's go ahead and solve this here. 3 plus 4 is going to equal 7. And on the other side, 4 plus 3, changing the order doesn't change the value. If you add 4 to 3, you start with 3, go up 4, you get to 7. If you add 3 to 4, you start on 4, and add 3 to that, still gives you 7. So the answer is 7 equals 7. Same thing here, 3 times 4. If you have 3 and you multiply it by 4, that means you have 4 sets of 3. So that would be 3, 6, 9, 12. Same thing goes for 4 times 3. Now you have 3 sets of 4. So 4, 8, 12. So you still get the same answer regardless of what order it's in. So how can we apply this in mathematics? Whoops. Well, one of the good things about the commutative property is that it tells us that regardless of how we put these, regardless of what order we put them in, we'll get the same answer. So if you look at this, generally in an expression with a variable, we put the coefficient or the number first. So something like 5xyz would be generally how we write an algebraic expression. However, all of those are being multiplied. 5 is being multiplied by x, which is being multiplied by y, which is being multiplied by z. Excuse me. So the relationship between all of them is multiplication. That means we can rewrite it as zxy5, xzy5, yz5x, etc., etc. However you want to do it, we really have no particular reason to put it in any order other than coefficient and then variables in order of alphabetics, because that our minds work easier that way. If you see something 5abc, your mind can decipher that easier than something like 5cba, right? So how can we actually use that? Well, if we're looking at this, we want to solve for y. So firstly, we have this expression zy6x equals 2y squared. So the first thing I would want to do is actually go ahead and put this in order in the way my mind can read it. So first thing I would want to do is say this is actually going to be 6xyz equals 2y squared. And so putting it in that order, now I've got my coefficient in the front, so I know what my coefficient is, and now I can solve for y using the commutative property. So firstly, I use the commutative property to just put them in an order that made sense to me. And then I'll show you another way how we're going to use it. So we want to solve for y. So the first thing we want to do is divide both sides by y. So I'm going to say divide by y and divide by y. And we get 2. Let me go back. Let me lower this real quick. There we are. Okay, so we divide both sides by y. So we're left with 6xz equals 2y. So now it was 2y squared. We divide by y, we get just 2y, right? And so now we have 6xz equals 2y. So now you may be thinking, well, why isn't it 2 over y, right? And that the commutative property tells us why. Because both the 2 and the y are being multiplied by each other, when we divide by y, we're essentially multiplying it by 1 over y. And so that y squared is going to cancel with the y in the denominator. This next example may explain that a little more. In order to get y by itself, what do we have to do? Divide by 2. So, divide both sides by 2. Anything that you do to one side of an equation, you want to do to the other. So we're going to divide that side by 2, and we're going to divide this side by 2. And so, and I'm going to actually just write it over here. If we have 6xz, and we want to divide it by 2, in multiplication, what are we actually doing? We're multiplying it by a half. So we're going to say multiply by 1/2. And so now if you're looking at this, again, it's all multiplication. So what we can actually do is rearrange it in the form of 6. And what I'll do is, let me stretch this out a little bit so you can see it just a little bit better. What we can actually do is rearrange this as 6 multiplied by 1/2 multiplied by x multiplied by z. And so now when we look at it, it's very clear that 6 multiplied by 1/2 is going to give us 3. And x and z don't actually have to interact with that half because the 6 has already gotten rid of it. So that makes our final answer, got rid of my thing, hang on. That's okay. That makes our final answer, well, no, I don't want to get rid of my thing, so let me go back up here. Well, it's not coming. Okay, that makes our final answer, 3xz equals y. And so you can see by rearranging the actual terms of that 6xz times 1/2, I was able to clearly see that my coefficient was going to be reduced to 3. However, the x and the z don't actually have to interact with that half. So hopefully that made sense to you. Hopefully it cleared a couple of things up about the commutative property. If so, make sure you hit that like and leave a comment down below. Visit lovettlearning.com for more videos, and I will see you next time. Take care.